If you are currently leveling up your Django skills with this tutorial is part of a free YouTube playlist. The link to the whole playlist is in the video description. Now, if you love this tutorial and playlist, then you might also like to check out the whole course, Django Database ORM Mastery on Udemy. The link to the course, which should provide the best price, can be found in the video description. The default behavior in a Postgres environment is that whenever we create a new database, Postgres automatically creates a schema named public. Unless otherwise specified, any database objects that we create from that point, such as tables, views, functions, they are all created in this schema named public. So the fact is that if you have already utilized a Postgres database, you have already been using Postgres schemas. So let's take a look at what a schema is and some of the benefits and how we might utilize it within our project. A schema is a collection of logical structures of data. This might include tables, views, functions, constraints, indexes, sequences. So if we take a look at the design that we've been working with so far, like I previously said, the default behavior in Postgres is whenever we created these tables and our functions for our trigger, for example, that is all placed in the default schema. Now, there are 4 reasons why you might like to consider managing your own schemas in your Postgres environment. One of them is for organization. So you can imagine having or setting up multiple schemas. Let's imagine, for example, we created a schema called S1. So this is the S1 schema. And then we go ahead and create a new schema, S2, so schema 2. So what we're able to do here is to logically separate resources, tables, like I said, tables, views, functions, constraints, into separate logical areas. So you can imagine, for example, you created a new database, you wanted to add, say, a couple of tables of that database in the first schema, and then you placed the rest of the tables of the same database in schema 2. Now, the benefit of that, there are 4 potential benefits here. One for organization, means that we can group related tables, because these tables in the S2 here, that might be related to, say, users, that might be related to user data, and then up here, these tables that have been placed in the first schema here, that might be related to, I don't know, products. So by creating schemas, we're able to logically separate tables in the same database. So by doing this, we're grouping related tables and objects together for maybe better structure. Now, this structure, if you like, feeds into other benefits of using a schema: security, manageability, and namespace. So by creating these different schemas, we can apply permissions at the schema level for improved security management. So imagine, remember, these tables here in our schemas that we placed are part of the same database. Imagine we had user 1 and user 2. What we now have the ability of, by utilizing schemas, is to apply permissions at the schema level, so that we can say user 1, for example, might have access to schema 1, but we can then, because we've logically placed these tables here in the schema 2 in a different schema, it can mean that potentially we don't want to allow access to user 1 to those particular tables in the same database, of course. So by utilizing schemas, we can apply permissions at this schema level. And of course, we can then allow maybe user 2 who may have access to that and can have access then to the schema 1. Now, depending how you look at this, this can both simplify database management by compartmentalizing objects, but at the same time, it can also make things a little bit more complicated because there's some extra layers, extra considerations to manage. So to conclude here, compartmentalizing objects into schemas enhances manageability by organizing related objects, preventing name collisions, controlling access, simplifying maintenance tasks and improving collaboration. So this structure is particularly beneficial for large or complex databases where clear organization and security are paramount. This type of implementation, this type of structure is going to be particularly beneficial for larger or more complex databases where clear organization and security are paramount. If you take a look at the new database design documentation, you will now see I have updated it to include the two schemas that we're going to build in order to introduce Postgres schemas in our project. So I've now updated the database documentation to include the two new schemas that we're going to build. One for our Django models related to the inventory schema. So the schema is called inventory schema, and then a separate schema called inventory management schema. Now you may have noticed that when we migrate our Django models over to our Postgres database, it in fact also creates a new table called Django migrations, and this table is designed to record all the history of the migrations that have been applied on the database. So by creating schemas for the Django migrations and logically separating this table from the other tables in this database, that's going to potentially provide us additional capabilities when securing our database tables and resources. So take, for example, let's imagine our Django application needs to connect to our database to manage our database. That is probably going to require access to Django migration, so we would create a new user for that purpose. In comparison to that, let's imagine we have an API or multiple APIs connecting to this database. The likelihood is that they won't require access to the Django migrations table. So we're able to lock them out of utilizing that table by applying permissions at the schema level, because we've managed our tables in a way where we are using schemas to logically separate resources from each other. Of course, there's a whole host of reasons why you might utilize this. For example, different teams can work with their own schemas, for example, without interfering with each other's projects or objects. This can promote better collaboration and reduce the risk of accidental changes. I spoke about easier management before, so grouping objects into these schemas can simplify tasks such as backups or restores and migrations. You can operate at a schema level rather than dealing with the whole database at once, particularly if you've got a really large database. This can be very beneficial. Something else that this then opens up to us is the ability to use schemas to separate the development, testing, and production environments within the same database. This can help in version control and deployment processes. There is a whole host of different options and capabilities and features that this will open up, and hopefully we will start to explore that as we work through this course. Right, so at this point, we now have 3 exercises to work through. First of all, learn how to create and manage PostgreSQL schemas, and then the important topic of schema search path. And then we'll go ahead and put this all together and integrate it within our existing project. This, like I said in the introduction, will provide us an extra layer for us to consider when developing our structural tests.